For the first 2 days, the Apollo 13 mission was looking like one of the smoothest flights of the Apollo space program. In fact, the Apollo space crew brought a camera with them and broadcasted on live television on how safe and comfortable the Apollo 13 spacecraft was. However, 9 minutes later, an explosion occurred in oxygen tank 2. This explosion also caused a leak in oxygen tank number 1. Now the command module's regular supply of light, electricity and water was lost. And to top it all off, they were about 200,000 miles away from the Earth. The crew heard a loud bang. This was, of course, the explosion in the second oxygen tank. Swigert looked up and saw a red warning light. He spoke into the mic. "Houston, we have a problem here." In the next few minutes, the Apollo crew realized that the bang was caused by the second oxygen tank. Now the warning lights flashed up again and indicated that the Apollo 13 spacecraft had lost 2 of the 3 fuel cells. These fuel cells, put together, provided Apollo 13 with enough electricity for the journey. Water was another concern. It was estimated that the crew would run out of water about 5 hours before re-entry. The ship needed water to help cool different mechanisms and the different modules. To help preserve water, the crew cut down to 1/5 of their normal intake of water. Another problem was the removal of carbon dioxide in the air. They had some lithium hydroxide canisters, which would help them remove the carbon dioxide from the spacecraft, but they were not compatible with the lunar module. However, Mission Control helped them attach the canisters to the lunar module by using some plastic bags, cardboard and tape. After they had sorted out all these problems, they had to come up with a solution on how to get back to Earth safely. They found out that if they could get close enough to the moon, they would be able to use the moon's gravity as a sling to propel them back to Earth. It worked, and the 3 astronauts lived to tell the tale. There were 4 more Apollo missions that took place over the next few years. The whole point of these Apollo missions was to collect important data on geological features. In these Apollo missions, the only thing that changed on each mission was the place where the spacecraft was supposed to land, and also the different kind of ALSEP used. ASLEP stands for Apollo Lunar Surface Experiments Package. These ALSEPs were small scientific experiments that the Apollo teams brought with them to space and set up on the moon. These scientific experiments sent the data home to Earth to be examined. Apollo 11's experiments consisted of 3 scientific experiments: the passive seismic experiment package, the lunar dust detector, the lunar ranging retroreflector, and lastly, the solar wind composition experiment. Because the ALSEPs used on the Apollo 11 mission were fairly primitive, they are more commonly known as EASEPs, which stands for the Early Apollo Surface Experiments Package. The Passive Seismic Experiment Package, or PESP, was used to measure meteorite impacts and moonquakes. It was able to measure this by using its 4 seismometers. It got its power from 2 panels of solar cells. The light energy from the sun was converted to electrical energy, allowing the PESP to run smoothly. However, this meant that the PESP was only able to run in the day. The Lunar Dust Detector, or LDD, measured the amount of dust on the lunar surface. It also measured the infrared energy and the temperatures of the lunar surface. The Lunar Ranging Retroreflector, or LRRR, was used to reflect light beams back to their origin. Scientists on Earth shone laser beams at the LRRR, which then reflected back. By using this piece of equipment, scientists are able to find precise measurements of distances. The ALSEPs in Apollo 12 to 17 were very different to the ones in the Apollo 11 mission. This was because all of the experiments were linked up to one central station. The central station provided power to the rest of the experiments and also sent data and received commands from the Earth. It communicated with the Earth with transmitters, receivers, data processors and multiplexers. In total, there were 12 different ALSEPs. The Lunar Passive Seismic Experiment. This experiment measured extremely small vibrations on the lunar surface. The vibrations are caused by various things, including distant moonquakes, man-made explosions, meteorite or spacecraft impacts. This particular ALSEP was used on Apollo 12, 14, 15 and 16. The Lunar Active Seismic ALSEP was very similar to the passive experiment. The only differences were that this experiment was only used to study one single area of the moon in detail. Also, rather than waiting for a natural event on the moon to produce shockwaves, the active experiment produced its own. A thumper was used to explode small, shotgun-like charges, whilst a motor contained 4 grenades that were launched after the astronauts had left the moon. This ALSEP was used on Apollo 14 and Apollo 16. The heat flow ALSEP was designed to measure the heat loss from the inside of the moon. For this experiment, 2 3-meter holes were drilled into the lunar surface, and several thermometers were placed at different points along the shaft. This experiment was used on Apollo 15, 16 and 17. The Lunar Surface Magnetometer, or LSM, was used to measure the variations of the magnetic field of the moon. The device could measure changes in the amplitude, frequency and direction of the moon's magnetic field. The LSM was capable of measuring all 3 factors with the sensors located at the end of the 3 small booms. This Apollo experiment was used on Apollo 12, 15 and 16. The Lunar Dust Detector, or LDD, measured the amount of dust on the lunar surface. It also measured the infrared energy and the temperatures of the lunar surface. This experiment was used on Apollo 12, 14 and 15. The lunar and solar wind experiments were made up of 3 components. The solar wind spectrometer, which was able to measure the energy, density, direction of travel of the solar wind and its variations. This ALSEP was used on Apollo 12 and 15. The second component was a superthermal ion detector. The purpose of this experiment was to measure the number and types of ions, which are positively or negatively charged atoms, on the moon. The third component was the cold cathode ion gauge. This and the superthermal ion detector was able to measure the number and types of ions on the moon. The solar wind composition experiment collected atomic particles released by the sun into space. After 1 hour and 17 minutes of it being exposed, it was taken back to Earth to be analysed. This ALSEP was used in Apollo 12, 14, 15 and 16. The Charged Particle Lunar Environmental Experiment, or CPLEE, was used to measure the particle energy of solar ions on the lunar surface. This experiment was only used on Apollo 14. The Lunar Atmosphere Composition Experiment, LACE, was used to measure the composition of the Moon's atmosphere. It was only used on Apollo 17. The Lunar Surface Gravimeter was used to confirm the existence of gravity waves, waves that travel at the speed of light, producing a gravitational field. This experiment was only used on Apollo 17. The Lunar Ejector and Meteorites, LEAM, ALSEP, was used to study the nature of small particles hitting the Moon and the force used when they are ejected back out. The LEAM contained 3 sensors in different positions. This meant it could measure the velocity and direction of impacting particles. This ALSEP was only ever featured on Apollo 17. The Lunar Seismic Profiling Experiment, LSPE, was used to measure vibrations in the Moon's crust. It was exactly the same as the other seismometers, but its design had been altered. This variant of ALSEP seismometers was only used on Apollo 17. These ALSEP experiments gave scientists lots of data from which they could conclude many things about the Moon and the solar system. Here are just a few of the conclusions relating to the Moon itself. That the Moon is made out of solid rock throughout and that it has no molten core. That the crust of the Moon is about 50 kilometers thick, with the crust on the far side of the Moon being thicker than the crust on the near side of the Moon. That the Moon has a weak magnetic field and doesn't have any poles. That the Moon contains no tectonic plates. That the lunar surface rocks are made out of the same minerals found on the Earth. These ALSEPs help NASA understand and distinguish various geographical factors of the Moon. Out of the rivalry of the Cold War had sprung a bold new quest to journey where no man had been before. Earth's greatest brains and bravest flight crew battled through adversity to the stars. Ad astra per aspera.
Oh, what a finish!